What is the wavelength of the wave? Include the units. Okay, well, fortunately, the wavelength is already labeled for us here. It's the distance between one wave to the next wave, from crest to crest, or from trough to trough, bottom to bottom. Up to you, but I usually like to do crest to crest. So let's see here, 2, 4, that's 3. 6, 8, that's 7. The units are centimeters, which makes sense because we're doing wavelength. 7 minus 3 centimeters. Okay, let's see how big that distance is right there. That distance, 7 minus 3, that is 4 centimeters, or 4 cm. Same thing. Okay, next question. The next question is, one wave pulse hits the end of the tank every 0.5 seconds. That's your period right there. Okay, you have to understand or remember what period is. Period is how much time it takes for one wave pulse to complete, one wave vibration. That's the period. Okay, and it's telling you one wave pulse hits the end of the tank every 0.5 seconds. That's basically your period. It's testing to see if you understand what period even is. That's what is happening here. Now the question is, what is the frequency of the wave? Okay, remember frequency is lowercase f, and frequency and period are related to each other in a formula. Yes, that formula is right here. So f is equal to, frequency is equal to 1 divided by t, the period. Do we have t, the period? Yes, it's given in the problem. So you have to understand the period is right here in front of your eyes. It says one wave pulse every 0.5 seconds. So all you have to do is plug in period, 0.5 seconds for your t. Okay, I know, period starts with the letter P, but its abbreviation is letter T. I know it's very confusing. So 1 is equal to 0.5 seconds. We're just plugging in the period here. And the answer is actually 2. And the units of frequency, remember, are hertz. Hertz. So again, the answer is hertz. 2 hertz, or 2 capital H-Z. You'll notice that I put second right here. Remember, 1 pulse per second is the same thing as hertz. Okay? All right, so again, the answer is 2 hertz. You can also write it like this. Next question. The next question is calculate the wave speed of the wave. Remember, wave speed is lowercase v, and we have to include the units for the wave speed. Okay, so here's the formula for wave speed. I will give it to you. No need to memorize it. The formula for wave speed is wave speed, lowercase v, is equal to frequency, lowercase f, multiplied by the wavelength, which is the Greek letter lambda. That's how you say it. Do we have the frequency? Yes, the frequency is given to us as 2 hertz. We just figured that out. Remember, you have to use that which you just figured out. The wavelength, do we have the wavelength? Yes, it's 4 centimeters. We just figured that out. If you forgot, well, let's go back. I'll prove it to you. Okay, let's see here. Okay, frequency, well, look at that, it's 2. And then, let's see, going back to the beginning, do we have the frequency? The wavelength? Yes, the wavelength was 4. So all we have to do is just plug it in, okay? Just plug it in. 2 hertz for frequency, and then 4 centimeters for wavelength. So when we plug it in, it's gonna look like this. Wave speed is equal to 2 hertz times 4 centimeters. Frequency multiplied by wavelength, okay? And this can also be written as this, okay? So 2 hertz right here is the same thing as 2 pulses per second, right? Pulse per second. So another way you can write this part of the whole formula is right here, 2 vibrations per, this line is per second, okay? If that's confusing to you, that's okay, you can ignore that. But I just wanted to let you know that 2 hertz and 2 per second are the same thing. You can write it either way. Okay, so all we have to do now is multiply 2 multiplied by 4. And the answer is 8 centimeters per second. Remember, the units, you need the units, centimeters per second. How do I know it's centimeters per second? Because if you do the math here, this is the reason why I told you that 2 hertz can be written as 2 per second, because 2 times 4 is 8, right? 2 multiplied by 4 is 8, and then you have centimeters in the top, you have a division sign here, and then seconds is in the bottom. So then the units end up being centimeters over the seconds, which is centimeters per second, okay? And that's why the answer is wave speed, okay? Remember, lowercase v is wave speed. Wave speed is equal to 8 centimeters per second. It's kind of like saying, like, if you're driving, right? If you're driving and you're going really slow, that's 5 miles per hour. It's the same thing. This little division line means per. Okay, it's the way you write speed. Okay, it's distance over a period of time. Okay, again, so your wave speed, this is the answer here. Wave speed is equal to 8 centimeters per second. Okay, so here's the next question. The person starts moving the paddle more slowly, decreasing the frequency. Remember, frequency is lowercase f. How does the wavelength change? Okay, so this is the wavelength. Okay, this is the symbol for wavelength. So it's asking you, this question is testing to see if you know the relationship between these two symbols in this formula right here. V is equal to F times lambda. We just used this to find the wave speed, right? So it's asking you if frequency goes down, if this guy goes down, what would happen to the wavelength? What would happen to the wavelength? The wavelength would go up. And the reason why the wavelength would go up is because to keep the whole formula balanced, if this guy goes down, this guy has to go up because they're on the same side of the equation. So let's pretend you're trying to keep the wave speed the same, right? If frequency goes down, you have to increase the wavelength. It's like if you're on a seesaw, like on a playground, and you have a kid here and a kid here, you want to keep the seesaw balanced, right? So if this kid goes down, then that means this kid has to go up to keep the whole thing balanced, okay? So again, the question is, how does the wavelength change, this guy, lambda, if the frequency decreases? The wavelength would increase, okay? Again, if frequency goes down, that means wavelength has to go up. And you have to understand why. That's the important question. Okay, so here's the next problem. We have this graph. This is a sound wave. Okay, notice here that the units on the horizontal axis are seconds, okay? It's not, it's a unit of time. It's not a unit of distance. So this tells you time, okay? And this is centimeters, of course, on the vertical axis here, the y-axis. Okay, so here's the first question. What is the period of the wave? Okay, so period, remember, period is how much time it takes to complete one pulse or one vibration, okay? One complete vibration, okay? Going back to the graph here. Okay, so look at that, one complete vibration. How do I know that's one complete vibration? Well, look here. You start at the bottom and you end back at the bottom. That's one complete vibration right there, or pulse, same thing. You can say the same thing. So the period is the amount of time it takes for you to complete this vibration. Wavelength and period are actually the same thing, but since the units on the horizontal axis here are seconds, you're measuring the period, the amount of time. So let's see here, 0.2, 0.8, okay, well, 0.8 seconds minus 0.2 seconds, that time difference is 0.6 seconds. So what is the period of the wave? Include the units. Again, the answer is 0.6 seconds. You can also write 0.6 s, same thing. Okay, next question. What is the frequency of the wave? Include units. Okay, remember frequency is lowercase f. Let's go back to that graph so we know what we're dealing with again. Okay, oh no. So frequency is not anywhere on this graph. You have to use the mathematical relationship between frequency and period, okay? So I will give it to you. Don't worry, you don't have to memorize any formulas. So frequency is equal to 1 divided by t, the period, okay? So in order to find the frequency, you first have to know the period. Do we have the period? Yes, we have the period. How do we know that? Because in the previous problem, the problem that came right before this one, it asked us, what is the period? Hello, we have that now. It's right here. It's right here, 0.6 seconds. So all we have to do is plug it in. Okay, so f, okay, frequency is equal to 1. Okay, so 1 divided by t. Do we have t? Yes, I just told you. We just figured it out. It's 0.6 seconds. Let's plug it in, 0.6 seconds, okay? And then the answer to this is 0.67, and the units of frequency, hertz. The units of frequency are hertz. Okay, so here's the answer. Okay. Next question. I know this video is getting kind of long, but a lot of you said that it's really helpful, so thank you for your patience and for doing this Edpuzzle. So let's do this practice problem. Given information, you have the wave speed given to you, 340 meters per second. Okay, that's how fast your wave is going. That's why it's called wave speed. Remember, wave speed is lowercase v. Okay, frequency is given to you. Okay, lowercase f. Frequency is given to you. And now the question is, what's the question? The question is, what is the wavelength? Oh, wow. Okay, remember, wavelength is this little guy, lambda. Okay. Okay, so looks like we have the wave speed, we have the frequency, and we want to find the wavelength. Now this is where students get a little scared because they're like, okay, I remember, Mr. Pham, I remember the formula for wave speed is lowercase v. Okay, this is wave speed. It's equal to frequency times the wavelength. So in this problem, what information is given to us? Let's check again. We have the wave speed, so we have this, yes, we have that. And we have the frequency, yes, frequency. Oh, but we have to find this. And a lot of students get scared because they're like, how do I figure this out if it's, how do we figure this out if it's all the way over here? Well, if it's all the way over here, what you have to do is first rearrange the formula to isolate the specific variable that you're looking for. Which variable, which symbol are you looking for? You're looking for this symbol right here. So then you have to rearrange this formula to get this by itself. That's what isolate means. So let me do that for you right now, okay? So wave speed is equal to frequency times wavelength. And we're looking for this, right? So frequency multiplied by wavelength. You have to do the reverse of this to undo it. What's the opposite of multiplication? Well, division. So then divide both sides by f. You want to divide both sides by f because dividing both sides by f is the opposite of multiplying by f here. And I'm trying to get rid of this f. I'm trying to get lambda, the wavelength by itself. So divide by both sides by f. Okay, so f over f, what happens there? They cancel out. Now look at that. You have this guy by itself. See that? Okay, so then, I'm just going to use the space up here. So then what do you have? You have this guy by itself, okay, is equal to what now? V divided by f. Do we have v? Yes, we do. It's given to us. What is it? It is 340, okay? Wave speed 340 is equal to 340, okay? And then frequency. Do we have frequency? Yes, it's given to us in the problem. It says frequency is equal to 1.67. So then the answer is, if you do the math, this is the answer right here. 203.59 meters. And why is the unit meters? Why is it meters? Because what are you looking for? You're looking for the wavelength. And wavelength is distance, okay?